In our Spectroscopy 101 video, we introduced you to the equipment and results that can allow for the identification of unknown luminous objects. There is more that we plan to accomplish with this valuable equipment. Spectra can show us not just the chemistry and possible origin of an object, but also the physics of the object. Let's take a look. In our first video, we briefly mentioned that color equals energy, blue having more energy than red. Well, from the color of the peak intensity, we can measure the temperature of the object. This is like having a remote thermometer. In our first video, we compared light sources that have line-type spectra with those that have a continuous band of light. Well, if lines are present, we can study them not just for the atoms and molecules that create the light, but also at least three very important physical measurements: magnetic fields, pressure, and velocity relative to us. Magnetic fields present at an object's source of light can cause some lines in a spectrum to split into more lines. And we can remotely measure the strength of that magnetic field at the object using this technique of spectroscopy. We saw in our first video a sodium vapor lamp warm up. As the pressure of the sodium increases with the lamp's warm-up, the yellow sodium lines broaden with increasing pressure, and this can be measured remotely by spectroscopy. You may have heard about Doppler shift. This is how astronomers know if objects are moving toward us or away from us. This is also how astronomers measure the rotational speed of galaxies. So, in the cases where the light that produces a line spectrum moves at extremely high velocity, we can potentially measure its speed relative to us based on the Doppler shift of the lines. This is a slight color shift that a high-resolution spectrograph can measure, such as the Echelle spectrograph mentioned in our first video. A shift to the red means the object is moving away from us, and to the blue means that it's moving toward us. All of these physical properties can be measured as they vary with time. So, if the lights are pulsing, or if the magnetic field or pressure is changing, or if there is a rapid change of direction of motion, spectroscopy can tell us remotely that this has happened. To complete this video, let's take a look at some example spectra that have already been obtained by one of our research consultants, Dr. Massimo Teodorani, for luminous objects that cannot be classified as known man-made or even known natural phenomena. When this occurs and we record and document it, as shown here, we have the chance to learn something new about the universe and the world around us. It is truly remarkable that many in the field of science today seem to want to shut their eyes to the possibility that there is some new physics or chemistry or even other life origin that exists which just doesn't fit our comfortable view of the world and the universe around us. So, this is why the UFO Data Project was chartered. We greatly appreciate your time in viewing our video and visiting our website. Look for new updates regularly. We certainly appreciate your interest in the work that we are doing, and we appreciate your involvement to help us advance an area of science that is greatly neglected today. Thank you.